Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for tonight will be trigonometry, lesson number 28, and the title of the topic is Sine of the Sum of Two Angles. The topic for tonight will be one of the foundations of trigonometry. This is a very important topic because when we go to the problems involving sine of the sum of two angles, we will be using these formulas, and actually we could use these formulas that will be derived for tonight in the so-called study of integral calculus. Okay, let's proceed. The subject matter for tonight, it's a long video format. The topic is on trigonometry, and we are now on lesson number 28. So for those of you who are following my long video format discussion on trigonometry, we are now on lesson number 28. And this is one of the most important topic under the study of trigonometry. The sine of the sum of two angles. Normally, we are only taking the sine of a single angle, normally. Right? We are familiar with this one. Okay? But if we are given the sine of the quantity a plus b, okay, that will be another story. And that will be our topic for tonight. So we will be deriving two trigonometric identities used under the study of trigonometry for tonight. And this will be the first one. And this should be the second one. So if you want to, what do you call this, study trigonometry and pass it with flying colors, you should memorize this sign of the quantity a plus b and the sign of the quantity a minus b by heart. Okay, so for tonight, for me, I don't like to use a certain formula if I could not derive it. So if I could derive it, I better bring out the so-called derivation. Because the important thing here is if you know the derivation, it is actually easy to memorize the formula. And if you forgot the formula, if you know the derivation, you could derive it. Okay, let's try to bring out the sign of the quantity a plus b. And the next one will be the sign of the quantity a minus b. Okay. These two here are complicated things. It's not the same as just simply taking the sign of a single angle. It's a different story. So for tonight, we will be deriving the complete expansion of the quantity sine of a plus b and sine of a minus b. For this one, since I've been teaching more than 33 years ago, actually I could still memorize this one. If it is sine of a quantity a plus b, I just place it. Pardon me with my, what do you call this, code. I will just say sin cos sin, meaning sine cosine, cosine sine. Okay, that's my code. Meaning I will take the sine of the first angle, cosine of the second angle. If this is plus under sine, this should be plus. Cosine of the first angle, sine of the second angle. For the negative sign, I could still memorize it. It's still a sin cos sin, meaning sine cosine, cosine sine. But if it's under minus, this should be minus. So meaning to say the expansion of this one is the same as this one, but if this is minus, this should be minus. So it should be sine of the quantity a minus b will be sine of a cosine of b. If this is minus, this should be minus cosine of a sine of b. 33 years ago, I could still recall it from my head. But the problem is, I could still derive it, so there will be no problem. Okay, let's proceed with the so-called derivation. Okay, I will try to erase this one, so it will look good. Oh, we are given a circle here. Okay? and we'll try to draw two right triangles. The first right triangle involving angle A will be this is point O, Q, no, P, this is Q, this is N, this is M, and this is R. The first triangle is actually this one. It's a triangle OQN. OQN. Okay? If I will try to bring out this one, it is this. Right? The other angle is actually angle B. This is angle B. If we try to bring out angle B, the resulting right triangle will be this one. Angle B is actually from, okay, point O, okay, Q, and P. That's it. So these triangles here emanate from this one. So I will try to repeat it. This is angle A. This is the first radius. The second radius is this one. The angle between angle A and angle B, this is angle B, the smaller one. So the first one is angle A, this is angle B. So from the horizontal line up to the second radius, that will be the sum angle A plus angle B. And I now try to, I brought out already the resulting right triangles emanating from this. This is the first one, this is the second one, this is the third one, and this is the fourth one. We needed these ones here in the so-called derivation of the formula. Okay, so if I will try to bring out angle A, this should be lit point O, okay, point N, and this is point Q. This is angle A. The other equivalent of angle A, it will be this one. It's a little bit complicated, but it will be, I will show you like this one here. If this is angle A, this should also be angle A. How come is that one? If this is angle A, this should be angle A. It was derived like this. Considering the triangle OQN, if this is A, this angle here should be 90 degrees minus A. Right? And this next one here should be angle A. Because this is a horizontal line, this is a vertical line, so if this is 90 degrees minus A, this should be A plus A. Okay? And this one here, this is a perpendicular line. This radius here and line PQ are actually perpendicular. This is in 90 degrees. So if this is angle A, this angle here should be 90 degrees minus A. Okay, so if this is 90 degrees minus A, of course, this angle here is angle A. Okay, you got this one? Right? Oh, that's the explanation why if this is angle A, this should be angle A. It emanates from this. This is angle A, this should be 90 degrees minus A. This one should be angle A. This should again be 90 degrees minus A. Okay, and this should be angle A because 90 degrees minus A plus A is actually 90 degrees. This is a right triangle. Okay, let's try to bring out the derivation. Oh, the other triangles are actually this one. For angle B, if we try to bring out angle B, where is angle B? Oh, this is angle B. The right angle here is here. So for angle B, this is point O. Okay, this is point Q. And this is point P. Okay, the right angle is here. Okay. Or the bigger one, considering angle A plus angle B. Okay, angle A plus angle B, it is this one, right? So if we try to bring out this triangle here, the angle is actually angle A plus angle B, it is this. This point here is point O. Okay, this one here is point M, right? This point here is point P. Okay, this is a vertical line, this is a horizontal line, so this is actually a 90-degree angle, and this point here, it was designated as simply R. Okay? We needed these 4 right triangles in the so-called derivation of the sine of the quantity a plus b. Okay, let's proceed. Considering this triangle here, in which the included angle inside is the sum of angle A plus angle B. If we try to consider angle A plus angle B, this one, this is opposite side, this is adjacent side, this is hypotenuse. So if we try to take the sine of this one, it should be opposite over adjacent, right? Opposite over hypotenuse, right? It should be PM or PM over OP, right? But from the given figure, PM is actually the sum of PR plus MR. This length here should be equal to this plus this. So it is actually MR plus RP, all over the same OP. And if we try to look at the given figure, what is MR? MR is actually, where's MR? MR. This is MR. Right? It is the same as NQ. So I place it here. MR is the same as NQ. So instead of placing MR here, I will place NQ. So this will now be NQ plus RP. I'm just repeating this one over OP. Okay? There are 2 numerators under single denominator. We could expand. So this be NQ over OP plus RP over OP. Okay, we segregate it. Then we'll try to make some algebraic manipulations. I will rewrite NQ. Am I still on camera? Oh yeah. I will rewrite NQ. Then I will rewrite OP. Then I will introduce OQ. OQ. The distance OQ. Because OQ over OQ is actually 1. So if this is 1, it seems it is still NQ over OP. But I could write it as simply NQ over OQ times OQ over OP, the first one. I introduce this one. There's no violation. That is algebraically. You can insert something on the numerator and denominator as long as they are of the same value because they cancel out, right? For the second one, I will rewrite RP. Then I will rewrite OP. Then I will introduce PQ. I will introduce PQ. Because a PQ over PQ is actually 1. This is 1 actually 1. But I could place it as PQ. This is a PQ. Okay? So actually we are given 4 fractions now. First fraction, second fraction, this is plus, third fraction, fourth fraction. And what is the equivalent of this one? Let's go back to the first right triangle. The ratio NQ over OQ is actually sine of angle A. Okay? NQ over OQ is sine of angle A. It is sine of angle A. What's the next one? Let's go to the angle B. Angle B. Angle B is, what's this? OQ over OP. OQ over OP. Considering angle B, this is adjacent side, this is hypotenuse. So if we try to take the cosine of this, it should be OQ over OP. So actually the ratio OQ over OP is actually cosine of angle B. It is this. Okay? What's the third one? Still angle A. We'll go to angle A. Angle A, but we'll consider the second right triangle. This second triangle actually emanates from this one here. Okay, this one. The ratio RP over PQ, considering angle A, this triangle actually this one here, right? It's different from this one. This is the same angle A, but the equivalent of angle A in terms of the other values will be this one. So if we try to take the ratio PR over PQ, that is actually cosine of angle A. So this is actually cosine of angle A. the ratio PR or RP or PQ is actually cosine of angle A. And the next one, it refers to angle B. We'll go back to angle B. For angle B, the ratio, for considering angle B, this is opposite side, okay, this hypotenuse. If we try to take the sine of this, it should be PQ over OP. So PQ over OP is actually sine of angle B. Okay? It's not a magic because there are four fractions here, and there are equivalents of this one. And the equivalence of this one actually emanates from the individual right triangles that was taken out from this one with the proper designations. Right? Angle A, this is angle B, this is angle A plus angle B. We place all the dimensions, so when we get the ratios, we will not be hard up in taking visualizing what is sine and cosine, right? Like the first one, sine is actually NQ over hypotenuse, right? OQ over hypotenuse is cosine. It's cosine. So at least we now know where this emanates, the four fractions here. That is NQ over OQ will be sine of angle A, and OQ over OP will be cosine of angle B, and RP over PQ will be cosine of angle A, and the ratio PQ over OP is actually sine of angle B. Right? So if we now try to combine this one, the operation here is multiplication, guys. This is multiplication, multiplication, multiplication. So first fraction times second fraction plus first fraction, second fraction. The first fraction here is sine of angle A. Second fraction is cosine of angle B. The operation is multiplication, meaning we will take the product of sine A, cosine B. This is plus, right? And again, the operation here is multiplication. This is cosine of angle A multiplied by sine of angle B. So in general now, under the study of trigonometry, from now on till we die, the sine of the quantity angle A plus angle B close quantity is actually, I could still memorize, sin cos cosine, right? Meaning sine cosine, cosine sine, it's a plus, right? So sine of the first angle, cosine of the second angle, if this is plus, this should be plus. Cosine of the first angle, sine of the second angle. This is a general identity under the study of trigonometry for the sine of the sum of two angles. So try to memorize this by heart. Okay, let's try to derive the second one. Supposing the operation here is subtraction, what will be the expansion? Okay, so we'll derive that one. So in general now, if we try to replace A and B for the meantime by the value x and y, and following this, sine of x plus y, by following this, I introduce x and y. So it will be sine of x cosine of y plus cosine of x sine of y. If this is plus, this should be plus. Okay? If we try to derive the value of sine of the quantity a minus b, we will place x equal to a, and we will place y equal to negative b. Okay? For it to be negative. So if we try to substitute this value here, back here, sine of open bracket a plus open quantity minus b, close bracket, equal to sine of a, right, cosine of negative angle b, it should be negative, it's negative, plus, well, following this, cosine of angle a, sine of negative of angle b. And if we try to simplify this one, it will be sine of a plus cosine of b. I will explain this one. Cosine of a, it's this. This is times negative sine of b. This is negative. This is plus, but this should be minus. So if we try to simplify this one, I will explain this one. Sine of the quantity of the difference a minus b should be equal to sine of a, cosine of b. If this is minus, this should be minus. So the cosine of a, sine of b. So for the sine of the quantity a minus b, if this is minus, this should be minus. How come we place this one as negative sine of angle b? It is something like this. From the given figure, angle A is actually measured clockwise, right? Counterclockwise, so it's plus A. So if it is measured counterclockwise, it falls under, this is it falls under the fourth quadrant, right? An angle that is measured clockwise is negative. So this is negative angle B, right? On the first one, it is plus B because it is measured counterclockwise. But if it is clockwise, it should be negative, right? This should be the angle. This side here should be plus. And this side here, the vertical side will be minus. And the hypotenuse will be plus. So if we try to take the sine of sine and cosine of an angle that falls on the fourth quadrant, sine of the negative angle B, we'll just use the sine. What is sine? Opposite over hypotenuse. A minus over a plus, so it's minus. So meaning to say, the sine of an angle that falls on the fourth quadrant, meaning sine of negative angle B, is negative sine of angle B. It is this. It's this. So this negative sine of angle B actually emanates from this. We derived this one. We did this one from the previous lesson. And for the cosine of negative angle B, cosine is actually adjacent over hypotenuse. But this is plus. The hypotenuse is always a plus. So a plus over a plus will be a plus. So the cosine of negative angle B will be positive cosine of angle B. It is plus. This is plus. Right? Plus cosine of angle B. This is negative sine of angle B. So in general now, the sine of the quantity, the difference of angle A minus angle B will be sine of angle A, cosine of angle B. If this is minus, this should be minus. Cosine of angle B, sine of angle B. So at least we now know where this minus sign emanates. It comes from this. Okay? That's it. Okay? So we have derived the two most important formulas under the study of trigonometry. That is the sine of the sum and difference of two angles. Sine of angle A plus angle B is sine of A, cosine of B, cosine of A plus sine of angle B. If this is plus, this should be plus. For the difference, sine of the quantity A minus B will be the same. Sine of angle B, cosine of angle B. But if this is minus, this should be minus. Cosine of angle B, sine of angle B. Okay, that's it, guys. Okay? The next time around, we will be deriving the tangent of the sum and difference of two angles. Okay, good evening from Los Angeles. Professor David G.